Okay, so I gave you this worksheet in class. I just want to go over it as an activity on the video rather than a full lesson. 3.4 is operations on functions. I think yours said 3.3 by accident, so go ahead and change that to be 3.3. Also, this is something some people do in 140 on the composition. Some people touch on that as well. I'm just going to go over some simple, the basics of operations on functions to give you a little leg up into pre-calc. We do teach this in pre-calc, but I'd like you to be familiar with it before you get there so that it's just one less thing to think of. But don't worry too much. We won't have, this won't be heavily tested or anything like that. So that being said, let's look at some examples and some things to know. Okay, so we have here, we can combine two functions by adding, subtracting, multiplying, dividing, etc. The thing that makes this interesting is that the result will be a new function with a new domain. So that's kind of the big concern that we want to make sure that we have. We'll have existing inputs that work to start with, because if it, and then with whatever the finished up function ends up being, that also has a domain where inputs work into it. Because if we start with something undefined, it's just meaningless to the new function. One other thing is we want to emphasize the fact that we do get a new function, or we can use some new notation. So when adding two functions, they have f of x plus g of x, we can actually write that as f plus g of x. The new function is named f plus g. Same goes for subtracting. We would have f of x minus g of x equals f minus g of x. And it's named f minus g. If we're multiplying two functions, same thing. F of x times g of x, sometimes the dot's there, sometimes not, is f times g of x, or fg times x. Some publishers use this a lot. Most of them use the little dot. So one thing to think about too, this dot, say how it's a solid dot to indicate multiplication. There is a different kind of symbol that's an open circle that means composition, and we do that in pre-calculus. You'll see it a little bit in this book, but this same book kind of overlaps with the pre-calc, so I have to pluck out the curriculum that fits college algebra versus pre-calculus. When dividing two functions, f of x divided by g of x, or we might have f slash g of g and then all of x, the new function is named f slash g, or f divided by g. Finding the domain of f plus or minus g, or fg, is really just a matter of stating all real numbers that are in the domain of both functions. Intersection of domains of f and g. So we're going to have to use the word and, not or this symbol that is the intersect symbol. When finding the domain of f divided by g, you must also be sure that g does not equal 0. So we can't have a 0 in the denominator like in these examples. So let's get into some grunt work here. It's pretty straightforward for some of them, but then it gets a little tricky. Okay, so for examples, we have let m of x equal 3 divided by x minus 5 and p of x equal x minus 2 over x plus 3. I think this is going to give you some good fraction practice. That's why I chose this, even though it's one of those kind of things that's optional and we can plant seeds. I think it's really reviewing some good skills and reinforcing what functions are. So we can split this apart it to write it as m of 2 plus p of 2. Then we're going to plug the 2 into the m function and then the 2 into the p function. So that I'm sure you can do on your own. So go ahead and pause the video, do that, crunch the numbers, try to do it without a calculator and get that fraction refresher going. Part B, I'm going to set you up for that one too, because I want you to notice here it's P minus M, not vice versa. So be careful when you do that when you're going to do P of M. P of 2 minus M of, and that should be negative 2. Let's just get rid of that. So P of negative 2 minus M of negative 2. And just watch your P function is the one that's given second in the up above. So I just want to clarify that. When I first looked at this, I did it the other way around and it kind of comes out the same, but the sign would be different. So don't want you to get tripped up with that. So go ahead and pause the video, see what you can do with that. If you're not sure at all, just come right back and start it up again. Okay, so for the part A, 1A, I just wrote it out for you. B, I'll do with you in the video, and if you've gotten it right, you can skip over it. So the answer for A should be negative 1. We just plug the 2 in everywhere we see an x. Here for the m function, we get 3 over 2 minus 5, and then added to 2 minus 2 over 2 plus 3. That equals 3 over negative 3 plus 0 over 5, which equals negative 1 plus 0. So the fractions work out really nicely and easily for us on that one. So that all equals negative 1. For part B, your answer should actually come out to be negative 25 over 7. So if you got that, then you can just go ahead and skip over this part. But if you didn't, then you can watch the video. I'm also going to jot down the answers for C. That should be 2/5. So if you want to try that on your own and just know if you got it right and then move on, because it's kind of more of an activity than a lesson. So I want you to be trying some. So C is 2/5 and D is negative 1 over 18. E is pretty challenging. You need to split things up and be careful how you do that. One thing to note, we don't distribute over function notation. So I'm going to talk about that after we go through this page. But just be careful and write everything out separately. Unless you're comfortable rolling those together as a function. Let's see. So the answer for E should be negative 2/3. So if you want to try those and see how you do, if you're feeling pretty comfortable with it all, it's going quick, then you can just skip over this part of the video. Okay, so we are back up to B, and I'll walk you through that one if you need help. So we're going to plug in negative 2 into the P function. So make sure you look at the right one. That's kind of half the battle there. So we would have negative 2 minus 2 in the numerator, negative 2 plus 3 in the denominator. We can put parentheses to just clarify that that's one piece. Here we also can put parentheses. Since we don't have an expression in the top, though, we don't need to worry about it too much. But then I have 3 over negative 2 minus 5. So now I'm going to have to work with my fractions. So this first one, negative 2 minus 2, and gives me negative 4, and that'll all be over 1. So that's kind of nice. And then I have a negative 3 over negative 7. So that actually is going to become positive So I can just put my pluses in there so I don't forget. And then get a common denominator. -4 would be -28/7. You can just kind of think how many times does, or what's 4 times 7 is the easiest. And then +3/7. So my answer on that would be -25/7. For part C, now let's look at this one. M times P of 0. So we're going to do M of 0 times, I could put a dot or not, P of 0. So M of 0, just go ahead and plug a 0 in up here for X, and P of 0, use this other function to the right. Okay, so I went through part C, just plug in 0, crunch your numbers, you get 3/-5 times -2/3. That gives us -2/-5, and that gives us a +2/5. So be careful with that. I did see on the tests, some of the tests, that people aren't simplifying that negative to be a positive. So that's something that should be done for full credit. You'll get points off for that kind of thing. Another thing to note too is that what we're entering in, is that in the domain, and so we should be setting our domain as well. So let's just make a little note up here that the domain for M is X cannot equal 5, and the domain for P should be X cannot equal -3. So we have to watch for that situation, especially for part D here. If we are having a division, we have M divided by P of 4. So we would write that of M of, or -4, M of -4 over P of -4. So we have to just make sure this fits the P domain, because it's in the denominator too. And we also have to make sure that it's going to fit into M, because even if we started wrong, we're not going to get anywhere legit. So go ahead and plug those values in. This one gets a little bit messier, but we have numbers to work with, so it's easier than letters. So we have 3/-4 minus 5, all divided by -4 minus 2 over -4 plus 3. Now that will simplify to, let's fix that, 3/-9, all divided by -6 divided by -1. So I can simplify some things before I multiply by the reciprocal. So I would take this 3 divided by -9 and make it be -1/3. And the -6 over -1, just make it be 6/1. And then how that should look is -1/3 times the reciprocal here, 1/6. And so my final answer is going to be -1/18. For part E, it gets a little more complicated. We have M minus P of X, that we want to find the average rate of change from x equals -1 to x equals 2. So we have m minus p of 2. We're just going to pick this second one. That's normally how we do it. And then that's that first chunk minus the second piece is m minus p of -1. All divided by 2 minus -1. So we can do these pieces off to the side and work the math. So I'm going to do that over here. I'm going to find m of 2 first. So m of 2, I think I figured that out earlier, didn't I? M of 2 worked out to be -1 from before. So I can just use that number because m minus p of 2, remember, is m of 2 minus p of 2. So that would give me -1. And then I figured out p of 2 was going to be 0, so -0. So I get -1. So you could redo it, but I'm just using from up here. Here I was adding, but I'm subtracting this time, but it's just 0. So it comes out to be the same answer. Then the second piece is m of, that kind of looks funny, but that's a -1 in there. So m of -1 minus p of -1. And that one I don't believe I've found yet, so have to crunch all the numbers for that. So what we get is plugging in -1, we get 3 over -1 minus 5 minus -1 minus 2 over -1 plus 3. And all that works out to become negative, well, it'd be 3 over -6, so -1/2. And then minus, we would have a minus 3 over a 2. Then again, we have a negative there, so we want to make that be positive. So we will end up with 2 over 2, which equals 1. So now this top piece back over to here, we figured out this chunk m minus p of 2 is -1. And we figured out that m minus p of -1 is also 1. So we're going -1, -1. And then this would be 3 in the top. I mean in the bottom, sorry. 2 minus -1, it gives us a 3 in the denominator. So that all works out to -2/3. So that's kind of more complicated. We do more of that stuff in pre-calc. So if that one is just kind of like, forget it, I don't want to think about that one again, that's totally fine. I did want to point out a couple of things here and how we don't want to, what's called, some people think they can distribute the things, like they might say, I could just kind of find the difference of those x's and plug that in to the functions and figure it out. Well, that's not going to work. But let me show you a little side example. So I'm going to go back up the top of the page and put it up there.